Bismillahirrahmanirrahim. Assalamu alaikum dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. Our today's lecture is about structure of alkyl nitriles according to hybridization. The general formula for alkyl nitriles is RCN. And in this video lecture, we will discuss the example of alkyl nitriles, that is methyl nitrile or methyl cyanide. But prior to starting this example, we will discuss the structure of hydrogen cyanide molecule, because this is a simple example and we will start from the simplest case to the complex structure. So now let's begin. So first of all, in the case of hydrogen cyanide, as this structure consists of a triple bond between carbon and nitrogen. So in the case of alkynes, the triple bonded carbon atom follows sp hybridization, and this would also show sp hybridization because it also has one lone pair of electrons. So in the case of these sp hybrid orbitals for nitrogen, one sp hybrid orbital would contain this lone pair of electrons and one sp hybrid orbital would be overlapped with the sp hybrid orbital of the carbon atom. So the situation would look like this, as in the case of carbon, this is the one sp and this is the other sp hybrid orbital with one electron in each. Then in the case of carbon, it is further attached with the one hydrogen. This sp hybrid orbital is attached or overlapped with 1s orbital of the hydrogen atom, forming a sigma bond, and this sp hybrid orbital would be overlapped with the sp hybrid orbital of the nitrogen atom. So this would also form a sigma bond, and the other sp hybrid orbital would contain a lone pair of electrons, because if you see that the nitrogen, the atomic number of nitrogen is 7, that shows 1s2, 2s2, 2px1, 2py1 and 2pz1. So here these s and px orbitals intermix to form two sp hybrid orbitals. So these three electrons would be oriented like two electrons in one sp hybrid orbital and one electron in the other sp hybrid orbital. 2py and 2pz orbitals of the nitrogen are still unhybridized, and similarly carbon also has unhybridized 2py and 2pz orbitals. The 2py orbital of the carbon atom would overlap or would interact with the 2py orbital of the nitrogen, and in this way a pi bond would be generated. And there is another unhybridized orbital to both of these atoms, carbon and nitrogen. So here this unhybridized 2pz orbital, and here this is the unhybridized 2pz orbital. So both of these would also interact with each other to form another pi bond. So the pi cloud is actually above and below the sigma bond, because it is along the all sides of the vicinity So we may say that it is either above and it is on the both sides, or actually it is along the if we draw it in two dimensions, then it may be drawn either above or below the sigma bond. So this forms actually an electron cloud, or that is also called as a pi electron cloud. So this is one pi bond between two py orbitals, and the second pi bond would be formed between two pz orbitals. So in this way, this sigma bond is drawn like this between carbon and nitrogen, and this sigma bond between hydrogen and carbon is shown like this. These two pi bonds are drawn like putting the other two lines either above and below the sigma bond. So in this way, it has one sigma bond between carbon and nitrogen and two pi bonds. And nitrogen has also one lone pair of electrons and one sigma bond between carbon and hydrogen. But in the case of this methyl nitrile, what happens actually, all the story remains same, except here this sp hybrid orbital of the carbon interacts or overlaps with the sp3 hybrid orbital of this carbon atom. So in this case, there would be another sp3 hybrid orbital of the carbon atom. So it has the same case as the structure of methane, with the only difference that there is one hydrogen atom would be replaced by the sp hybrid orbital of this carbon atom. So here the rest of the story would look like this. This is the sp3 hybrid orbital, this one. And there are three other hybrid. Okay, so let me draw it clearly. So this is the sp3 hybrid orbital of this carbon atom with two electrons or overlapped regions. So here these are the sp3 hybrid orbital, this is also sp3, and this is also sp3 hybrid orbital of the carbon atom with one electron in each of them, and that would be overlapped with the 1s orbital of the hydrogen. Because here these three hydrogen atoms have been satisfied like this: one sigma bond with this hydrogen, one sigma bond with this hydrogen, and one sigma bond with this hydrogen. In this way, these three sigma bonds would be formed with these three hydrogen atoms, and rest of the structure would be same as drawn here. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.